And I'm going to use this probability box device, which I happen to be very pleased with. Okay. So here's my box. See, when chalk doesn't work, you don't have to send it back to the manufacturer. You just grab another piece. Okay. So suppose so this is the world of people. Okay. We could even say it's the universe of employed women. Fine. I'm going to divide it two ways, into two sets of hypotheses. The first one, which I'm going to represent on the bottom horizontal dimension, is, and this is obviously not to scale, but I'm going to say, look, half of the universe consists of bank tellers, and the other half, maybe I should just use my stylus on the chalkboard, is not bank tellers. And I'm going to use a piece of set theory notation. This little thing here is the symbol for not, the complement of, right? So not bank teller is the subset that is the complement of bank teller. I can then subdivide bank tellers into, I can also subdivide the world into feminists, okay? What am I doing? Yeah, no, I can't. So a feminist and non-feminist would be a third dimension. But I can divide the world into feminist bank tellers, and then everybody that isn't a feminist bank teller, okay? People, not non-feminist bank tellers, but people who are not feminist bank tellers, which includes a bunch of these people here, of course, are non-feminist bank tellers. So I guess I probably should not have made this the universe of women, because a lot of those people are going to be men. Okay, fine. So in some sense, right down here, I've got on this dimension down at the bottom, I'm going to work with your probability assessment of how likely it is that Linda's a bank teller, and up here I'm going to work with how likely it is you think she's a feminist bank teller, and we're going to do sort of base rate neglect on both of these things. Okay, now let me suppose that 75% of feminist bank tellers are liberal, or maybe to be more specific, exhibit all of the signals that we got in the description of Linda. Okay, so this is the conditional probability that you're liberal, given that you're a feminist bank teller. Okay, and I'm just going to call it 0.75. I'm just making up numbers, probably higher. I'm going to lump non-feminist bank tellers and non-bank tellers together, and sort of just for simplicity, assume that they have the same probability of being liberal. Yes, I've made a mistake yet. This is people who are not feminist bank tellers, right? Which includes non-feminist bank tellers and non-bank tellers. Yeah. Okay, and I'm going to, so this here, is the conditional probability that you are liberal, given that you are, the conditional probability that you're liberal, given that you're a, that you're a non-bank teller, which is going to be equal to the probability that you're liberal, given that you're a non-feminist bank teller, right, is going to be equal to 0.25. I think I've written that right. Yeah, basically what I'm saying is that the probability that a bank teller is liberal, that a non-bank teller is liberal, is the same as the probability that a bank teller who's not a feminist is liberal. Mathematically, that can't actually be quite right, but I'm just simplifying things, and it won't affect the outcome. All right, now, to do my little graphical thing, as we did last time, let's just give these numbers 1, 2, 3. Okay, and now we can actually write out Bayes' rule first using these little labeled areas, and then using actual math. Okay, so here's what Bayes' rule says. This is the right thing to do. All right, down here. Yeah. So we see the signal liberal. The probability that you're a bank teller, given that we see the signal that you're liberal, which is equal to the probability of the conjunction bank teller and liberal. That's area 1. The ratio of that, like what proportion is that of all the different ways that you could wind up being observed to be liberal, and that is equal to 1 over 1 plus 2 plus 3. Okay. Meanwhile, the probability that you are a feminist bank teller, that you're a bank teller and liberal is 1 plus 2 plus 3, right? Probability that you're liberal if you're a feminist bank teller, probability that you're liberal if you're a non-feminist bank teller, 1 plus 2 or 1 plus 2 plus 3. Meanwhile, the probability that you're a feminist bank teller, given that you're a liberal, is the ratio of the conjunction feminist bank teller and liberal. The probability that you would be liberal, obviously, this is a subset of that, right? And in particular, that's 1 over 1 plus 2 plus 3. Okay, so that's the non-heuristic right way of doing things. Basically, I've just said the same thing about 3.5 different ways. Now, an interesting question, well, I think interesting, you may or may not agree, an interesting question is whether or not we might be able to explain this with a model that we already have based on evidence from other kinds of anomalies, which is a model of base rate neglect. Oh, wait a minute, I actually have to do that. And that brings us to here, okay? So if the signal is liberal, the hypothesis, one hypothesis is bank teller, another hypothesis is feminist bank teller. Suppose the following conditional probabilities are correct. So what I have here is, that's the 0.75 I just showed you, this is the 0.25, and then I came up with sort of the probability that you're liberal if you're any kind of bank teller, which is a weighted sum of 0.75 and 0.25. I'm stating that that's 0.35. That means that I've made an assumption about the percentage of bank tellers who are feminist. Turns out the assumption is I'm making is that 1/5 of them are feminist. Doesn't matter at all. Just take me at my word that there's a state of the world in which the probability of being liberal conditional on being any kind of bank teller is 0.35. And the question is, working in groups or alone, compute these two conditional probabilities under our simple model of base rate neglect. Yeah? Clear on what the exercise is? Okay, enjoy. Take some time. This is a little bit of work involved. Okay, raise your hand if you're going to get it in the next 30 seconds. Raise your hand if you are going to get it if I give you another half hour. All right, take another 30 seconds. Oh, this was really bad question design because you actually only have to compute the first one to get the right answer. Man, that was really dumb. Okay. Did you guys all see that? Right, right, okay. Okay, take another 5, 4, 3, 2, 1, and let's stop. Okay? All right. Now, how many of you have been keeping track of the distribution of A, B, C, and D among right answers in my question design? Because it's almost always A, and I've been noticing that I need to go and solve that problem. And the correct answer is A. So, let's see. Does anybody feel like walking us through just the math of the first of these two things, the probability that you're, the sort of base rate neglect, conditional probability of being a bank teller given that I observe you being liberal, or acting like a liberal? Yeah. So, sorry, all this semester I haven't known your name. Ina. 0.35 over 0.35 plus what? 0.25. So that is the probability that you are liberal given that you're a bank teller, right? Divided by the probability that you're liberal given that you're a bank teller plus the probability that you're liberal given that you're not a bank teller. Yep, and that's 0.58. Okay, so then you can stop and answer the question. Good. I promise not to make that error in designing the final exam. And then what you have here is the probability of being liberal given that you're, so basically the proportion of feminist bank tellers who are liberal divided by the sum of that proportion and the proportion of liberals among people who are not feminist bank tellers, which is 0.75 over 0.75 plus 0.25. Now, if you're astute, you will know that if you have A over A plus B, then the first derivative of that ratio with respect to A is positive. I think that's right. Yeah, because it's like the negative. I don't remember why. I'm not that good with calculus. The point is, so what did this wind up being? It wound up being 0.75. Right, so the point being that base rate neglect gets you the conjunction fallacy. It gets you that you wind up sort of, you use the model of base rate neglect, ignoring, basically what are you doing here? You're ignoring the fact that the base rate of bank tellers, the proportion of bank tellers, is just much larger than the base rate of feminist bank tellers, right? So it's the same thing as with the HID test. You're ignoring the fact that vastly more people are HID negative than HID positive. So what you're doing here is you're ignoring the fact that there's just way more bank tellers in the world than there are feminist bank tellers. It's the same exact mathematical sort of quasi-Bayesian error. And here we can see that we can explain a different anomaly, in this case, the conjunction fallacy. Now, to sort of see the psychology of representativeness bias in this math, right, what we have is the probability of, the probability of being liberal if you're a bank teller is greater than the probability, is less than the probability of being liberal if you're a feminist bank teller. That's another way of saying that feminist bank teller is more representative of liberals than bank teller is representative of liberals, right? This mathematical statement is why the model of base rate neglect gets you an explanation of, oh dear, sorry, yet another annoying feature. No, I'm just kidding. Does that work? Does that help? It's the podium? There's only two of you. This is the crucial parameter in so many benefit cost analyses. The hell with the minority. Okay, so the fact that this conditional probability is greater than this one is what's driving the results that we get from this mathematical model, quasi-Bayesian model of base rate neglect. It also captures the psychology of the representativeness heuristic. I'm going to go for the thing that looks most right. This is basically saying that this hypothesis looks more like the signal than this one. Okay? Right, which is to say, look how representative it is. They're almost the same thing. Right? The set of people who are feminist bank tellers is almost the same as the set of people who are liberal feminist bank tellers. All right. Let me know if you want me to say that 3 more different ways. Okay. Yeah, I said that. Okay, shifting gears a little bit. New iClicker on your own, no chit-chat. How likely do you think the following statement is to be true? The statement is, more handgun deaths in the U.S. are homicides, i.e. murders, than suicides. Okay? I think that's very likely, somewhat unlikely, very unlikely. Do not think about it too hard. Go. Come on. 5, 4, 3, 2, 1-ish. Okay, what do we have? All right, so let's see, 42 plus 22 is 64, so 64% of you think it's more likely than not. All right, good. Anybody feel like they want to say why? I mean, first of all, let me get a show of hands. How many of you know the statistics with certainty? There's a few of you that actually know. I don't want to know what your answer was. Those of you who don't know, what did you base your answer on? For a very, very short period of time, it will be very painful. And then no more pain, which is kind of the point. But okay, so you're just thinking white people wouldn't do that, but killing someone else with a handgun seems like on balance better for you. Yeah. Okay. All right. So some logic underlying that answer. Yeah.
I assume there's a lot more suicides than homicides.
Because otherwise, why would I be asking the question?
No, just a feeling. I think people are really feeling self-depression or something.
So you said you think the statement's probably not true.
I said
very unlikely. You said the opposite. You're thinking the murder rate is probably higher than the suicide rate by any means. Okay. Yeah. We're going to write a book together, but it's going to be a children's picture book. No, that's hilarious. Thank you. That was wonderful. And that's not correct in this case. So let me show you the numbers. Of course, you know that the answer is that it's not true. So where is that evidence? Whoops. Oh, I just had it written down. The truth is that as of 2010, there were 9,392 suicides by gun and 11,078 homicides by gun. So 61% suicides, 35% homicides. Okay, so you guys are wrong. That's fine. You're allowed to be wrong. But sorry, those of you who said you knew the statistics, you got the answer right? Or are my statistics wrong? Oh, yeah, that's scary. You should be scared. It's a big, oh, yeah. Yeah, this is not a pleasant country we live in. This is selectively pleasant, right? If you're lucky enough to be able to buy a home in a gated community, this is a lovely country. What? Yeah. This is according to the Pew Center, which is a reputable source. As of 2010, 19,000 suicides by handgun, 11,000 homicides by handgun. Yeah? Oh, 9,000 first? I said 19,000 suicides, 11,000 homicides. How many of those were people who were shot by a gun that's in the house? A lot of them. So anyway, I don't want to go into this. The politics of guns is just very, very strange to me. Okay. More evidence. Subjects asked to estimate the number of deaths by various different causes. I love this. Tornado, fireworks, asthma, drowning. Okay, so here's what people's estimates were, right? Like basically people thought that the number of deaths each year by tornado was about the same as the number of deaths by asthma. In fact, very few people die in tornadoes, and quite a lot of people die of asthma. Fireworks, not quite. Well, I guess that's an even bigger sort of proportional error. And then drowning people were way off too. So what do we think is going on here? Kahneman and Tversky, who we think you're supposed to read, this is a short paper, conjectured this is caused by a thing that they call the availability heuristic. Now, if you're like me, you read this stuff, and you think to yourself, now, how exactly is this availability heuristic different from representativeness? And to psychologists, there are fine distinctions that really matter. When I look at this carefully, I think it actually does matter, given the quasi-Bayesian approach we're taking. So here's the idea. The heuristic is, assess the probability of an event by the ease with which instances of the event can be brought to mind. So I'm paraphrasing the paper that's assigned. Okay? So more formally, we overestimate the probability of a hypothesis, conditional on seeing a signal, if it is disproportionately easy for us to call to mind instances of that hypothesis from among the universe of hypotheses that could lead to a signal of I. So what is the signal? The signal here is death. Somebody died. That's all we know. Somebody died. So we treat that as a signal, and then we have a whole bunch of hypotheses. And what the availability heuristic does, the rule of thumb, is it says, all right, well, how, sort of the mind basically, you're doing this, like literally in terms of neuroscience, your mind is actually digging into like different circuitry and saying, let me find a synapse. So let me find a little bit of circuitry that has observations of death by tornado, memories, things I know about death by asthma, death by fireworks. I mean, if somebody dies in a fireworks accident, it's etched in your mind, right? Like, whoa, that was gruesome. And so basically, your mind just goes in and just pulls out the thing that comes out most readily, the thing that's most available. Literally, it's almost like reaching into a box and those the thing you put in 50 cents and you have a grappling hook and you steer it around and you grab like a bunny's head or a basketball or something like that. You don't go for the thing that's hard to get. You go for the thing that's easy to get. That's the availability heuristic. Okay. Here are some reasons why some things might come to mind. There might be greater ease of bringing things to mind. Okay. So there's retrievability. So we think that sort of the way that memory works. I am way out of my depth on the neuroscience here, by the way. We have some idea that the way that memory works is that a thought or an image or something gets imprinted on the mind, it actually creates some kind of circuitry, some kind of synaptic connection. Happens again, it strengthens the connection, right? And so the more times that we've observed an event, the sort of stronger that circuitry gets, the easier it is to pull that back out. Okay? And so, in terms of like a useful rule of thumb, it's a pretty natural assumption to guess that the frequency of observation is proportional to the true frequency. So you're walking through the world and you're looking at sticks and you're looking at snakes. And if your path through the forest is actually sort of a representative sample of the forest, the frequency with which you see sticks and the frequency with which you see snakes, which is to say the frequency with which these things get imprinted on your mind, is going to be pretty much the same as the true proportion of sticks and snakes in the forest. Okay? In simple circumstances, we observe things that are common more frequently than we observe things that are uncommon, right? The problem arises when our observations of reality are not based on a representative sample. Okay, so in reality, in many cases, less frequent events are observed more frequently, or with greater salience. Okay, so here it's pretty right. I mean, we don't have tornadoes here, so nobody cares unless they're a fan of Alice in